Well, good morning, good afternoon, good evening, or good whenever time you are watching this video. Mr. Mouche here. I hope y'all are doing fine. I know a lot of us are a little tired of staying cooped up in our homes, but it looks like that we're going to have to start back with school again, but online. This is my first lesson with you. We are still in circles, and I told you, before our spring break that we still had a couple more weeks or so of circles before we go into volume. So anyway, we're going to try and see how this works. So I'm going to be presenting you with a slideshow, and I'm going to show you step by step, what is expected on this lesson. And then, of course, I'll have future videos for future lessons. Feel free to pause at any time. So if you need to, work a problem out and see how it's done and take good notes on it. And then at the end of the video, I'll tell you about a assignment that you'll have to complete. And by watching this video, you'll see how it's done, and hopefully you'll understand it and you'll do well on the assignment. All right, so here we go. I know y'all don't want to look at me anymore, so I'm going to go straight into what we're going to be talking about, which is arcs and their inscribed angles. Now, everybody look at this example number 1, Roman numeral 1. Here we have in our circle an angle that's not coming from the center, but it is actually coming from the edge of a circle. So anytime you have chords that meet at an angle at the edge of a circle, you form what is called an inscribed angle. Now, this inscribed angle has a relationship to the central angle. Now, if y'all remembered when we were covering angles or central angles before, we always said whatever the central angle is, that is the measure of the arc. However, when we have an inscribed angle, then you're going to get a different measurement. Well, what is that measurement? All right, so bear with me as I bring up a pen here. Okay, so let's say, for instance, this is 60 degrees. Then we know that the arc up here is also 60 degrees. This right here is our inscribed angle. Now, the relationship goes as we have, excuse me, a central angle and its arc measure. If you just simply take that arc, divide it by 2, you will always get the inscribed angle. So 60 divided by 2, the inscribed angle will be 30 degrees. And it's that simple, that easy. Now, since this is 30, let's say we wanted to go backwards, and I said this was 40 degrees, then this angle up here, or I'm sorry, the arc would be 80 degrees. Alright, so if you need to pause and take note of it, you can. Alright, our second scenario. Now this one's a little different, but also the same, because now you've got several inscribed angles. So you got A, B, C, and D. But there's a unique relationship going on. Now, everybody look at angle A. Now, angle A, we're going to say is 20 degrees. Now, since this is 20 degrees, and we go from angle A all the way to its intercepted arc. I'm going to tell y'all that before. This is the intercepted arc. So 20 times 2, and that would give you 40 degrees. But look what else is going on here. since this is 20 and it's going to arc BC, look at angle D. Angle D is also going to arc BC. Alright, let's see if I can get a different color here. Highlight it. So here is angle D, and it is going to arc BC. Since this is 40 degrees, then that means angle D is also 20 degrees. Sorry, I gotta get used to these pins here. 20 degrees. So, in this scenario, angle A is congruent to angle D because they go to the same intercepted arc. Now, let's look at B and C. Notice how C goes to arc AD and angle B goes to arc AD. Since angle B and angle C goes to the same intercepted arc, therefore angle B is congruent to angle C. Now, looking at this, let's say angle C is 35 degrees. Think for a moment, what's angle B? Also 35 degrees. And when you go from inscribed angle to intercepted arc, you double it. So 35 times 2, 70 degrees. And if you take 70 divided by 2, you get 35 and 35. So this is case number 2. Now let's go to case number 3. Okay, case number 3, we have a diameter. Now, if y'all remember, diameters make up half of a circle. Okay, so it's going from edge to edge through the center. And if we have 360 degrees in a circle, therefore, this from here to here, of course, would give us 180 degrees. Well, if this is 180 degrees divided by 2, you will have your angle measure, okay, which is a right angle, or 90 degrees. Now, this is one of the most difficult ones for students to remember or recognize because students tend not to look at this diameter. So you need to make sure that you are looking at, or if seeing or noticing that you have a diameter given. Because if you have a diameter given, this angle here will always be 90 degrees. Now keep in mind, I can place this anywhere I want in the circle and I'll get 90 degrees. So I could go here and here. Because it's going to 180, this will be 90 degrees. Yeah, y'all notice how pretty my lines are here. I can't draw straight using a mouse. So this is 90 degrees. So it doesn't matter where you go, as long as you go into the diameter, this angle will be 90 degrees, a right angle. Alright, y'all remember my bad joke? It's always right. Derecha. Okay, now if you were afraid of it, you'd be scared, and that'd be to the left. But we're going right, 90 degrees. Sorry, I had to throw in this bad joke. Make sure y'all are staying awake with this. Okay, now here is case number 4. Case number 4, we have a quadrilateral that's inscribed inside of a circle. Every single inscribed angle is touching every part of a circle, and it doesn't matter what type of quadrilateral you have drawn, this case will work every time. Now if we were back in our classroom, I would actually have you draw these circles out, and we would take the protractors and you would measure it and you would test to see how this works. So what is the neat little rule here? Well, if you take angle A and you add it to angle C, you will always get 180 degrees. So in other words, opposite angles of the quadrilateral inscribed in a circle will always add up to 180. So if that's 180, these two would be 180. Alright, so let's say we have this. Let's see, where's my eraser? That's not eraser. Okay, there we go. Let's look at an example. Let's say this was 100 degrees. Well, all you got to do is look across. We know these are supplementary, so if this is 100, then angle C would have to be 80. And there you go, that's it. So students, if angle B is 120, what is angle D then? Well, these had to add up to 180, so D would be 60 degrees. And there you go. So this is what happens in case 4, scenario 4, in which you have a quadrilateral inscribed in a circle. Now let's review or look back at our first case again. Notice that no matter where you go in the circle, if you take 2 times the angle, you'll get the arc, or if you take the arc divided by 2, you'll get the angle. Now what I'm going to do is show you some examples. And as I show you each example, if you want to pause the video, take a piece of paper out and see if you can work it real quick, and then you can play it and then you can see if you are doing this correct or not. Alright, here we go. Example 1. Here we have angle A, or we're looking for angle A, and the arc is given as 158 degrees. Well, arc divided by 2 gives you 79 degrees. And that's the measure of angle A. Simple. Alright, let's look at this next scenario. This time I give you the arc, and we need to find angle A. Well, it's the same thing. Divided by 2, so 24 divided by 2, and you should get 12 degrees. That simple, that easy. Don't worry, it'll get a little difficult, more difficult a little later. So here we have an inscribed angle, but this time I want arc BC. So remember, got to go backwards. Instead of dividing, you are going to multiply. So 40 times 2, and arc BC is 80 degrees. Easy. Alright, everyone try this one. What is the measure of arc BC? Pause if you need to. Alright, so since I'm going from angle to arc, I'm going to multiply it by 2. So 76 times 2, 152 degrees. Okay, easy. Now we get to the complex stuff. Notice that our problem is asking for arc ST. Now here is the problem. Here's ST, but it gives us an inscribed angle 61 kind of adjacent to this arc ST. So what do? You are going to take the rules that I just taught you, and anytime you see any kind of angle in a picture, see if you can translate it to an arc. Or if you see an arc, translate it to an angle. So in order to find ST, let's start with this 61. I know this inscribed angle is 61, so if I multiply it by 2, I get my arc, which is 122. But where is 122? It's from T to U. I don't want TU, I want ST. Let's see, what else can we do? Here's the thing that students tend to leave out or miss. You got to check and see if you got some kind of diameter given, and there it is. We have a diameter. So since I have a diameter, I know that from here to here is 180 degrees. Sorry, that was bad. So since this is 180 degrees and this is 122, just take the 180, subtract 122, and we get a total of 58 degrees. And that is arc ST. Alright, next problem. Alright, now we're going to look at a couple of examples that's dealing with the multiple inscribed angles. So remember, since angle C and angle D are both going to the same arc, that means these two angles are congruent. And notice how angle A and angle B is going to, well, let's see where A is going. No, I'm sorry, here we go. We got angle E. Alright, so angle E is also going to arc AB. So it is also congruent to C and D. Well, let's look at some examples. So I need to find angle K. Notice how angle K and angle L are both going to the same arc, JM. Since this is 28, well, no, we don't need this arc right here. We just need to know what is K. So, since it's going to the same arc, these are equal. So, angle K is 28 degrees. Alright, apparently I've got some other problems coming up that I'll be using that method again in a minute. So, we'll come back to that. So, this next one must be number 3. Roman numeral 3, when you have diameter, we have 90-degree angles. Alright, so this is going to the diameter. So that makes angle B automatically 90 degrees. Okay, students, what's arc BC? Well, angle A is 90. That means this must be going to the diameter. Because remember, when you take an inscribed angle, multiply it by 2, you get the arc. So this would be 180. And then finally, our fourth type, in which we have a quadrilateral inscribed. And we need to find angle X and angle Y. Alright, remember, these have to add up to 180. The diagonals. Now, since this is 102, we can find X easily by going 180 minus 108. And when we do that, we get 72 degrees. But look at Y. It has nothing over here. Oh, but look, it has tick marks. So these are ticks. That means these two are equal. Well, what's the only number you can have in which those two will be equal that makes 180? Of course, it would have to be 90. Because 90 plus 90 is 180. You couldn't do 70 and 70, that's 140. You can't do 60 and 60, that's 120. So it has to be 90. Now another way to look at it would be that we could call both of these like Y, and that's a tick, that's Y. So you could say 2Y is equal to 180. And then when you divide it by 2, of course you get 90 degrees. Alright, now let's look at our complex problems. So our complex problems is going to get it where we're going to have to do some other scenarios and things to it to help us get to an answer. Alright, so pause the video if you have to right now. I want all of you to try to find arc AB. Okay, here we go. So I see a couple things going on. I have an inscribed angle, 120, and I see a diameter. So a diameter I know makes 180. Oh, that's terrible. Okay, y'all know I draw a lot better on my smart board. So this is 180 degrees. This is 20. Now what can I do with that 20? Well, that's an inscribed angle. So what I'm going to do is multiply it by 2, and that's going to give me an arc measure of 40 degrees for BC. Now notice I'm looking for AB. Oh, here we go. Well, since this is 180 and this is 40, just simply take 180, subtract 40, and you will get 140 degrees. And that's what y'all should have got for that one. Alright, let's look at our next example. We want to find the measure of angle JLM. Now, angle JLM is right here, JLM. Alright, now let's see what I got going on here. Now, this is where students start kind of messing up. Notice that 88 is not an inscribed angle. It's a central angle. So remember, central angles are equal to the arcs. So this is 88 from here to here. Now, what else do we got going on? Well, another diameter. If you see these diameters, write it in. Mark up your picture. That's 180. Now, what can I do with this 180 and 88? Well, it looks like I can subtract, and when I subtract the two, I get 92 degrees from J to M. Alright, now, what is this going to? Let me get my highlighter. So, here is my arc, JM, and notice that it's going down here to angle JLM is where I need. And so remember, you have to take your arc, divide it by 2, and that will give you 46 degrees. And this will be angle JLM. Alright, next example. We want to find measure of angle A. Alright, now this time I gave you an arc of 54 degrees and I need this angle right here. Well, this don't look too bad because notice here that I have a diameter, so we know that this is 180, and since this is 180 and this is 54, let's go ahead and subtract 180 minus 54. And this should give us arc BC. So when I subtract the two, I get 126 degrees. Now, since this is 126, there we go. I just need angle A. So divide the arc by 2, and that will give us our angle of 63 degrees. Real simple. Now, this problem has a distractor to it. Notice that we have two arc measures given and an angle. Now I worked this ahead of time, and there's a couple ways you can go about it, but I will tell you this: one of the arcs is a distractor. You actually really don't need it in order to answer the question, because the question is asking for arc VST, not ST, but VST. Okay, so pause the video, see if you can find arc VST. Okay, now here we are. We have 51 degrees. So what I'm going to do is I'm going to multiply the inscribed angle by 2, and that's going to give us 102 degrees from V to U. Now notice it's asking for VST. So our distractor actually is 39 degrees. We don't need that 39. All we need is the 102 and the 135, because we all know there are 360 degrees in a circle. So let's go ahead and subtract 135 and 102 from the 360, and this will give us 123 degrees. So it's 123 for arc VST. So this problem was easy as 1, 2, 3. Next problem. Alright, let's see what y'all can remember about what to do to find X and Y in this one. So pause the video, solve for X, solve for Y. Now we know that it is 180 degrees when you take an inscribed circle. So that means if I just take 2x, add it to 64, it is going to give me 180 degrees. Subtract 64 from both sides. And then divide it by 2. X should give you 58. Now you could always check your answer by plugging in 58, multiply it by 2, and then subtract it from 180 to see if you get 64. Now you do the same thing with Y. So I have 4y plus 64 equals to 180. And when you solve for y, all of you should have got 29. Also, real easy problem. I'm going to go ahead and skip over this one. It's basically the same thing. If y'all want to work it, you can. But let's go on to our algebra. Now, the algebra problems, you have to remember just simply the rules and then apply to it. So we know that when we take an angle and multiply it by 2, it's going to equal to the arc. So let's do that. 2 times the inscribed angle is equal to the arc. Now notice I could have probably said the arc divided by 2 is equal to the angle, but look what would have happened. You would have ended up with a decimal. So this would have been 4.5x plus 10.5 equal to 5x. You could work it that way, get the same answer, but it's always easier to multiply than it is to divide. So 2 times 5x gives us 10x. This is equal to the 9x plus 21. Now go ahead and subtract 9x from both sides. And x equals 21. Okay, just a couple more problems. Let's look at this one. Now on this problem, notice how we'll call this inscribed angle A and this one B. Both inscribed angles go to the same arc. Since they're going to the same arc, then we know that these two angles are congruent. So this is actually the easiest one yet, because all you have to do is set them equal to each other. So 4x minus 3 is equal to 2x plus 11. Subtract 2x. 2x minus 3 is equal to 11. 2x is equal to 14. So x equals to 7. Now be careful. They could ask you, what was the measure of angle B, or what is the measure of angle A. So of course you would have to plug it in. And we've got one more to go. Alright, so I want y'all to look at this problem carefully, see if you can solve for x. Alright, here we are back. Now, 9x minus 4 is a central angle. Since this is a central angle, that means this arc is equal to the central angle. 9x minus 4 is the arc. Notice how the inscribed angle is going to the arc. So we're going to do a little algebra, because 2 times the angle is equal to the arc. So let's write it. 2 times the inscribed angle is equal to the arc. Now, using distributive property, I have 8x plus 4 equals to 9x minus 4. We got the larger x on the right side, so we're going to bring the 8x over. So 4 is equal to x minus 4. Now add 4 to the other side and you get x equals 8. And that is it. Okay, so there's your PowerPoint on the lesson that we would have had if we had came back from spring break. I will be uploading, it should be uploaded by now, a worksheet assignment. Let me get it out so y'all can see what it looks like. Okay, it's a standardized test practice. Now, when you complete this assignment, at the bottom of the page, it's going to be in Word format, and it's going to have 1 through 8 on it. So what I'd like for you to do is, when you are working each one of these problems, you are going to type in the correct letter response. So like for number 1, there's A, B, C, D, E. So when you work the problem, what I like for you to do is type in, which letter response it would be next to that number. And then you should be able to upload it back to Teams where I can check your work. Alright, so that's our first lesson. I hope everybody could understand what I was trying to present to you. And I hope everybody is having a nice little break, and I'll catch you later.